start.
Okay, it's good.
Okay, so this chapter 22 is about solutions. And when you're talking about solutions, you remember when we talked about the classification of matter, and we said that all matter can be broken up into pure substances and mixtures, right? What are the two types of pure substances? You remember? Elements.
We might have to shut that other light off.
Okay.
It's
You're
creating.
not going to be able to see. I'll just turn both on.
Bad.
She's not going to see the PowerPoint anyways.
Okay.
You know what I mean?
There you go. It's better.
Right. Elements and what else?
Whatchamacallits.
Yes.
When two elements combine chemically, what is that called?
Compound.
A compound. Okay? Now, there were two types of mixtures. What are they?
There was like the one where you could see the stuff and then
Homogeneous.
Homo and
hetero.
Hetero. Okay, homogeneous and hetero. And hetero. Now, remember we also said that a homogeneous reaction or mixture is also called a what? Do you remember that?
Does it start with an S?
Uh-huh.
Segmentary or something?
wait. Solution, substance, no.
Solute.
Solution.
Sorry, I was trying to remember.
Solution. All right, so this whole chapter is about this.
Oh.
The whole chapter is about this one thing. Okay? So I want you to keep in the back of your mind that it is a homogeneous mixture. Okay? Now, Evan said something. A homogeneous mixture looks the what throughout?
Same.
The same. It's uniform. That's what homo means, the same. All right, so what is a homogeneous mixture? It's a mixture that has the same composition, color, density, all of that same throughout. Okay, so they give an example of the hummingbird and sugar water. If you take sugar and you dissolve it in water, can you see the sugar molecules?
No.
No. Right, so it's a homogeneous mixture, therefore it's a solution. Now, anytime you have a solution, you have two things. You have the substance that is being dissolved in something and the something that's doing the dissolving, okay? So, you have your solute and your solvent, okay? Your solute is what's being dissolved. So, in our example, which one, sugar or water, is?
Sugar.
This is sugar, right. So this would be your sugar. And your solvent is what's doing the dissolving, right? And that would be what in this example?
The water.
The water, right. Matter of fact, water is a lot of times called a universal solvent because most things will be dissolved by water, okay? I'm trying to find markers that actually work here. All right. So if you can't tell, all right, what they are, we're going to kind of go through this, or which one's dissolving which one. Whatever one's the smaller amount is always your solute, and whichever one is the bigger amount is your solvent. So example, oxygen and air, okay? Oxygen is dissolved in air. So oxygen is my solute, because there's a small amount of oxygen, for the solvent of all the air, or whatever it is, of the other things in the air, okay? Now you can have a solid, liquid, or gas solution, okay? So let's talk about some of these examples. So first of all, let's start with liquid solution. If you have a liquid solution, you can have, and I'm going to put on here, solute, solvent, and an example, okay? So an example, you could have a solid solute and a liquid solvent. An example of that would be sugar water. Sugar normally is what? A solid. Your water is usually a liquid, dissolves, and it makes a liquid solution of that. You could also have a liquid in a liquid. Can you think of when you dissolve a liquid in a liquid?
Chocolate, milk, and milk.
Chocolate syrup.
Or chocolate syrup and milk.
Perfect. That would be chocolate syrup and milk, or food coloring in water, or that stuff you put in water to make it flavored.
Or the Mio.
The
or-
Mio, yeah, or whatever that stuff is. You
Yeah,
know, it's liquid,
Kool-Aid
concentrated, right? If you buy juices and stuff, sometimes you can buy concentrated juice and add water, okay? So all of those would be examples, okay? So I'm gonna put on here chocolate syrup is what she said.
Mhm.
Syrup and milk. Okay, that's a great example. Okay, you can also have a gas in a liquid. Okay, so can you think of when a gas would be dissolved in a liquid?
Condensation.
Mm-mm. That's when liquids form from a gas.
They drink it a lot, I bet.
They
Soda.
do soda pop. Example.
Carbon.
Anything carbonated, okay? They take carbonation and they dissolve it in it. Also, if any of you have an aquarium, okay, you actually have to get the oxygen.
Like
You
the
have
bubbles.
to dissolve into the water for the fish if you have that kind of aquarium. Does that make sense? Okay? So this is all a liquid solution. Okay? You can also have a solid solution. Okay? An example of a solid would be you could have a solid in a solid. Okay? If you're doing a solid one, you could have solute, solvent. You could do brass. Those of you that are in band it's
Copper.
copper and I think it's copper.
What is it?
I don't
Something
think
else.
anyone is in band.
Is it iron? Not iron. I don't know.
I don't know.
It's something else. But anyways, but what they do is what makes up brass? Copper and something else. There's another metal and I can't remember what it is.
No.
I don't know. I can't remember.
Silver.
I can't remember. It'll probably tell us. But
What?
anyways, what I want to tell you is this, that when you have a solid, a lot of times you have to, zinc, thank you. So a lot of times what you have to do is melt these down, mix them together, and then let them solidify.
So they still count as a liquid if they're or
So they still count because at the end result, it's a solid. If you notice, whatever the end result is what the classification is, okay? It's very difficult to get a liquid or a gas to dissolve in a solid, okay? You can do gas solutions, and gas solutions are very difficult also. Pretty much you have to do a gas in a gas. An example of that would be our air, okay? That's about, the air solution is about 78% nitrogen and 20% oxygen. So the 20% oxygen is smaller, so oxygen is my solute, nitrogen is my solvent, okay?
They kicked you off again.
I did, okay.
Yeah.
Sterling silver, if you, like your silverware that you eat with is sterling silver a lot of times. Your jewelry is sterling silver. It's not pure silver, it's actually silver with a little bit of copper. Gold, all your jewelry and stuff like that is not pure gold. It's actually, you know, the carat system. It's a mixture of different metals. All right, so let's talk about how a substance dissolves. Okay, so if I gave you a sugar cube and put it in water, what would happen?
Does the sugar cube would dissolve? It might take a minute to dissolve.
Indeed, it would cheat you, no?
Christian and signed on.
Taylor. Hey.
I don't know if she can even see you. She can see Miss Helen.
Hi.
Oh, there's Dayton.
And here's Evan.
And then here's Evan.
He's Evan.
Hello, Evan.
Is this yours?
That is one. It's zoomed in. There, now you can see Evan. I can't see your head though. I can see your shoulders. There's your head.
I know you did. You did. So, which, I mean, that's fine. I said, I don't, I'm sorry. I just assumed that it's about,
T-pose.
I'm invisible.
right, and I feel bad, but,
Where did Evan go?
Where'd you
no
go?
more. Yeah.
You can't see me.
Okay, here we go. Sorry. So if I take a sugar cube, or if you take a sugar cube and you put it in your mouth, what happens?
Dissolves.
It dissolves, but tell me, describe to me what happens.
It melts, slowly getting smoother and smoother. While
Okay.
your mouth gets sweeter and it's gross.
Okay, that's a good description. All right,
Thank
so let's stay here. Okay, so you put something in, okay? If I'm doing a sugar cube and into water, which is my solute,
Water.
The one. No,
Sugar, and what's my solvent?
Water.
Water. Okay, so the solvent attacks, and what it does is it comes into the surface of a sugar cube. And if you've ever sucked on a sugar cube, it starts to get like little holes in it.
Yeah.
Do you know what I'm talking about? Okay, because what it's doing is it takes chunks and pulls it out into solution. Or if you, even a sucker, okay? If you suck on a sucker, it gets smaller and smaller and smaller and smaller, right? Because more of this will dissolve into the liquid. Yes?
Back in grade school, we made sugar pyramids.
Oh, uh-huh.
Well, I ate it. I ate one. The entire thing.
The whole pyramid, did you have a stomachache?
No.
Okay,
My mouth hurt a lot though.
yeah. Now, sometimes
Also,
you
I
can
think
put,
I had a
this is a
winter
sugar molecule. What happens if I put oil and water?
They kind of don't
Separate.
mix.
They don't mix,
They don't-
okay?
you can see the
So
separation.
you have to, for this process to take place, they have to go by the rule of dissolving, which is this. This is the rule. The rule is like dissolves like. And what that means is this, that if you have a polar substance, okay, something is polar, it will dissolve something else that's polar, okay? If something is non-polar, it will dissolve something that's non-polar. So let's review what polar means, okay, because we talked about this before, okay? So I'm gonna
There's
put,
a positive and a negative.
good job, Dayton, very good. So water is polar. It has an opposite. Remember when we talked about polar, we said they're opposites like North Pole and South Pole.
Yeah.
So water, which is H2O, so you have oxygen and your two hydrogens. This side is kind of negative, this side's kind of positive, so this is polar. If it's the same all around, it's nonpolar. Oil is an example of nonpolar, okay? So, when you have this, the water molecules, which is polar, and it's coming into the sugar molecule, okay? The positives are going to attract to what part of the sugar molecule?
Negative.
Right, because the rule opposites attract, right?
Yeah.
So the positive side of the water is going to attract to the negative, and then the negative side of the water is going to attract to the positive of whatever the substance, the sugar or whatever it is. Does that make sense? Okay, so the water molecules pull the sugar into solution, and it keeps pulling and keeps pulling and keeps pulling and spreading it all out, okay, throughout. So particles of liquids and gases move more freely than solids. So solids take a little while. Like if you've ever sucked on a sucker, right? It takes a little while if you don't chew it up, right? To get it smaller and smaller. Well, liquids, if you've ever put food coloring into water, does it happen pretty quick? It does. Within a few seconds, it's all spread out, right? And the same thing with gases. It's because those molecules are moving around really, really fast. So it's a faster process.
The Flash.
Yes, they're like the Flash. All right. Now, remember we said that when you have solids, okay, if I just stick zinc and copper next to each other, are they going to mix?
No.
No. Okay, you have to melt them, okay, stir them up in a liquid state, and then cool them. Now, let's talk about rate. What's rate mean?
The speed.
Right, how fast something happens. Okay, now there's certain factors that can affect the rate. Okay, how fast it dissolves. So rate is how fast. There is some different things that can happen with that.
Just sign this and bring it to the office whenever too.
Me sign it? Where do I sign? Sorry, I don't have my glasses on.
Transport.
Hi, Marcia.
What are you doing?
I'm filming notes for Kaylor.
I was filling out a paper for something. I wasn't involved with it here. Yeah, there was other things involved.
Okay. All right, sorry. I finally found a marker that's good. So rate is how fast something happens. So the first thing that we can do is we can stir it. I always think about, do any of you like sweet tea? Okay, so to put the sugar in, right, you could just dump sugar in and it all goes to the bottom, right? But you have to stir it. So when you stir it, you're bringing some of this solvent in contact with the sugar to dissolve it. Does that make sense? So stirring will make it go faster, okay?
You don't stir it, then it's like,
It just goes to the bottom. What's something else I could do?
Temperature.
Temperature, increase, most of them increase temperature. I will say, and this is, let's talk about a solid in a liquid, because we're gonna talk about gases in a minute. It's a little bit different, okay? So, if I'm doing like sugar, okay, into tea, the warmer the tea is, the faster, and the more, actually, which we'll get to later, the faster it will dissolve, okay? And there's one more.
Hot tea versus instant tea.
Huh?
Hot tea versus instant,
Instant tea, yeah,
or
definitely.
sun tea.
Or sun tea, yeah,
I
definitely.
remember this.
What's the third thing? Tell me this, what dissolves faster, a sugar cube or powdered sugar?
Powdered sugar.
Why?
Because it's more fine. Less stuff is together.
Okay, so you're close. Okay, so remember we had said this all happens on the surface, right? So the more surface that you can be exposed, right, the faster it's going to dissolve. So that's called surface area. So if we increase our surface area. Now to do this, to increase our surface area, you can grind it up. You remember that lab that we did with the cereal to get the iron out? Do you know what I'm talking about? Everybody
No, I
remember?
was sick.
You were sick. You were here, Dayton.
Oh yeah, we
You-
grinded up.
You ground it up. So if I had just taken that cereal and put it in the water and stirred it, do you think the iron would have came out? Probably not. It would have probably taken a long time. But since we ground it up into smaller chunks, it was able to pull that iron out of that cereal. Do you see that? Okay. So grind it up. Okay. That mortar and pestle, that thing that we used, will help it to make it go faster. Okay. Chris, we already talked about that, temperature. So each technique, whether it's stirring, crushing, or heating, will speed it up. And if you can do combinations, it makes it go even faster. So if I wanted to make sweet tea, what is the fastest way I could dissolve it?
Stir it.
Stir it and
Heat it up.
have it warm and
Crush it.
crush up the sugar. If I ground up the sugar or use powdered sugar, it's ground up, powdered sugar, hot, and stirring tea, it'll instantly dissolve almost. Does that make sense? So combinations of these make it even faster. Okay? Now,
Ooh, the pull.
hold on. If you have, we need to talk real quickly about a gas in a liquid, okay? A gas, well, we might come to it in a minute. I'll come to it in a second. Okay, so we're on the second section now, and we're going to talk about
You got
solubility.
kicked off.
I get kicked off? Okay.
You got kicked off forever ago. Listen, you know that.
That's okay. It's just all the same stuff. It's just pictures a lot of times, you
I
know.
like pictures.
I know you like pictures. So now let's talk about solubility.
Past like 3 times.
Okay. Make sure I spell it right. Solubility. Lots of vocabulary in this chapter, okay? So you need to make sure, and they're all pretty similar. Solute, solvent, solubility, right? Solution. If you notice a trend there, they like
They're all
SOL
sol.
words.
They're called Saul.
Alright, so
Taylor, this is section 2.
Yeah, solubility is the maximum amount of solute that can be dissolved in a solvent. So go back to our sugar and tea, okay? So you put sugar in, right, and it'll dissolve, but if you keep adding sugar, what ends up happening?
It gets too much and it can't.
It gets
dissolve
too
at all.
much and then it just goes to the bottom. No matter how hot you have it, how much you stir it,
Or how
right?
big it
It's right, or how big it is. There's a maximum threshold, and that's what solubility is. What is the maximum amount that it can hold? Now, I will say this, that usually we can increase that solubility with temperature. So a lot of times when they talk about solubility, it's at a certain temperature. And then if we increase that, we can increase our solubility, or how much that can be dissolved. So here it gives you a beaker up here. And it says, in 1 beaker, 1 gram of solute A dissolved completely, but an additional solute does not dissolve and falls to the bottom of the beaker. So this is what we're talking about. The sugar in your tea, you dissolve some of it, but then some of it went to the bottom, okay? Where on this one, B, yes,
We almost done.
a few more minutes.
Okay, so that's right.
Are you gonna be okay? Can you
Yeah,
hold
I'm
it? Okay.
fine for now.
Yeah.
Can you hold it, Heaven?
All right, now,
Carpet
so
bombs is all I'm saying.
that's okay. So different substances might be something different. Like if you use, do any of you use sweetener? right? So like a sweetener like Equal
Fake
or
sugar.
fake sugar.
Stevia.
Okay, now if you use a tablespoon of sugar and a tablespoon of stevia, it may not dissolve the same amounts, or a tablespoon of sugar and a tablespoon of salt, right? So every substance has a different solubility depending on its characteristics, okay, is what they're trying to get you to think.
Do not
Now-
use stevia as sugar. I put 3 packets of that in and it's stronger than regular sugar.
Yes, it is.
Whew.
All right, now
That's
you can
dead
use
wrong.
general
Regular
terms. You can use general terms, okay? The general term for solubility is concentrated and dilute. What does concentrated mean?
means that it's more together.
It doesn't go bad as easy in food.
Not necessarily, no.
No.
Concentrated and dilute.
Concentrated is
Concentrated
stronger,
is
like less
strong.
water.
Right.
Not
Less, don't say
Right.
water, say solvent. Because yes, usually it might be water, but not always. So concentrated is like if you've got orange juice, or we talk that meal stuff or whatever. That's concentrated, right? It's really compact and lots of stuff.
Orange juice.
Orange juice. If you buy frozen orange juice and
Tampico.
those things, right? That's a concentrate. Where dilute means it's weak. We call it weak, right? There's more solvent in there. It's the idea that if you make Kool-Aid, do any of y'all make Kool-Aid?
I do.
You
Yeah.
make Kool-Aid. Okay,
Kool-Aid,
so if you put too much water in it,
Tastes like crap.
yes, because it's dilute, right? It's too much. There's a right amount, and if you don't put enough in, it's really, really strong, right?
That's how I like it.
And strong. Well, that's okay.
That's what I do. I put a bunch of that in, and then I also put sugar in it.
All right, so now we don't really
Thank you.
like these general terms. We want to be specific. So we're going to use measurements, okay? So there's 3 classifications of saturation. Okay? And they are saturated.
Non-saturated and super saturated.
Good job.
Is that true?
Uh-huh.
Yeah.
Oh.
Yep.
Like I
That
said,
just seems so basic.
Non-saturated and super saturated.
Well, at least it's pretty easy to know now.
Yeah. It just like
We're not trying to trick you.
No
Okay, so let's
saturation
talk
has
about
none.
if
Super
it's
has like all of them.
okay, if it's saturated, it's at the maximum amount. It cannot hold any more, okay? Does that make sense? If it's unsaturated, it's below, right? Below the max, and you can still add more, right? You can still add another cup of sugar or whatever it is.
Overmax.
And super saturated is this, okay? Let me, is when you, usually with temperature, okay? When a substance is hot and you add the solute, okay? And then you cool it down. It has more than it should hold at that temperature, and it's called supersaturated. So let me show you a graph, okay? So if I had a graph, and what they do is they figure out the amount of solute that can be dissolved per temperature, okay? And there's a graph up here, a bunch of different ones. So they're gonna put temperature down here, and then the amount of the salt. Okay, so what that means is this. If it is saturated, pay attention, okay? It's on the line. So at this temperature, it will dissolve this amount of solution. That's saturated. It's the maximum amount, right? If I'm below the line right here, all right?
Not saturated.
At this temperature, right, and this amount, I can still add this amount more, right? This is unsaturated. This is saturated. Does that make sense? It's below. I can still add up to this line to be saturated. Now, supersaturated is you get a hot liquid, you saturate it, then you cool it down. Does that make sense? So then you're actually right here. You're above the line. This is super, and it's very unstable. A lot of times, if you touch it, it'll crystallize really quick. And on YouTube, there's all kinds of videos of like water that you can, like, it's liquid and then you pour it and all of a sudden it solidifies. Or
Like
there's
wax.
I don't know about wax. I've never seen wax, but there's other ones too that if you just touch it, it all of a sudden goes and makes all these crystals and
can
stuff
we
like
do
that.
that?
Yes,
see.
let us. That would be dope.
But have you ever made Hard Rock candy? It's the same kind of idea that you get it really, really hot and then you cool it down and it crystallizes because it's super saturated. It has to take that solid out of the solution liquid if you do it that way. Anyways, okay. So unsaturated and super saturated. So this is a picture. So on this side, they've got these tongs up there. Can you see that? It's got a little crystal. They drop the crystal and it goes over there and just instantly and made solid because it was unstable.
That's Crystal 2.0.
All right, the last thing I want to talk about is energy. Okay, now sometimes when you do this, when you do solutions and solubilities, you release energy. If you release energy, it's what? We did this already. Is it exo or endo? If it releases
Exo.
energy, it's exo, right? So sometimes it's exothermic, sometimes it's endothermic. Example, when you have those cold packs that you break, right? It gets cold, right? And it gets really hard and solid. So that would be endo.
What about a glow stick?
The glow stick would be exergonic, right? Because you're mixing two little liquids. That's why you have to snap that and mix them together, right? Okay, because you're mixing them and it makes. All right, now we need to talk about the solubility of gases, which is different than the solubility of a solid and a liquid, okay? And when you hear solubility of a gas, I want you to think about pop, okay? So, when you think about solubility of, I'm gonna find a marker that's gonna work the whole day.
Someday, that probably won't.
Of a gas and a liquid, okay? So I want you to think about pop. Okay, so if we want, when you have more gas in a liquid, it's got carbonated. Y'all know carbonated and flat, right? Everybody okay with that? So, tell me this. If you stir your pop, is it gonna be more carbonated or less carbonated?
Less carbonated.
Less carbonated. So we want it to be carbonated. We want it to be dissolved in there. So you are, number one, no stirring or shaking, right? Because if you stir or shake with a solid, it makes it dissolve. But with a gas, it makes it come out. It makes it not dissolve, okay? It's opposite, yes.
Why does my mom always says that if you squeeze like a 2 liter, it keeps it better longer? Why?
Yes, because the air, what happens is, okay, and I'll show you real quick here. So you have a 2 liter, let's say like this, okay, and you have popped this line, and you just have it sitting here. There's going to be bubbles that escape into this pocket here. But if you squeeze it, you make that line go up to here, and there's less room for some of that carbonation to escape. So it's actually a good thing. If you leave that, you make sure it's tight and everything, so yes, okay. So no stirring. Also, tell me this. Which one has more fizz? Hot pop or cold pop?
Cold.
Cold, okay? Because when you heat up something that's gas, it wants to leave, right? Where, remember when we were talking about solids and liquids, we wanted to stir it, we wanted to heat it up, right? This one, when it's a gas and liquid, we want it to be cold and no stirring, okay? To get more of it to dissolve. Does that make sense? So, also with gases, you need to have pressure. You need to increase your pressure. So with this, if you leave a pop with the lid off versus having the lid on, which one's more carbonated?
With the lid on.
Right, because there's pressure in there, right? When you open up a can, it goes psst, right? Because you're releasing that pressure, and then the bubbles start to come up. Or when you pour it, the bubbles start to come up and come out of it. Does that make sense? So, we want to, those are the 3 stipulations for gases in a liquid.
Yay.
Okay? Any questions?
Nope.
All right. The worksheets are on the screen.
I got mine.
Okay? And is anybody going to be gone next week for anything other than the normal Monday, Friday?
We're not gonna be.
Are you gonna be gone,
Is that a
Dan?
track meet?
On Friday.
What?
Are you gonna be gone?
When?
Anything
Thursday?
next week?
Thursday.
What's Thursday?
don't know.
Pals.
You're going to be gone Thursday.
I think Kayla is too, because she's an FFA
She's a leader.
officer.
I
Okay.
heard her talking about that in class.
So I'm trying to figure out, because I wanted to have, we're not going to be able to have the test then. We'll have the test that Monday. I hate having tests on Monday, but we're going to just have to do it.
Can some people take the test on Thursday?
I went ahead and put all of them on there. So what you want?
No,
Oh.
for this class,
Oh, it hasn't
22 and
combined.
23 is combined.
I know, I'm gonna redo the test.
Okay, 'cause
Yeah.
they are not going to do 23.
We are, but we're gonna do it, like, we're gonna test 22 and then, yeah, cause I don't wanna wait that long, so I'm gonna redo
Okay.
the test, yeah.
Okay, cause that's what I was working on. But
Oh,
okay.
sorry.
You're gonna go eliminate 1 6.
Yes,
So,
yes,
Okay.
so, yeah.
I saw when you put your thing on online, you did 20, was it 22.1 and 22.1?
Oh,
I saw
That's
it when
the
you put it
typo.
on the screen.
it's 2, 21.2.
Yeah, I know.
So yeah, so we'll probably have the test, yeah,
Monday.
that Monday, what, the 29th? Yeah. Because, yeah, we still have to do 22.3 and 22.4. We're not gonna do a lab for this chapter. We're gonna just wait
We're
and,
not?
yeah, we just don't have time, because we've got to get to acids and bases.
Okay.
So we can some people take it Thursday.
That would be really hard.
Okay.
I know it's kind of crappy. I don't like having tests on Monday, but we're just gonna have to do it.
Are you done?
Yep, I'm done talking, sorry.
Mm.